or invasive species? Are we? We're about to find out.
A lot has changed in our country. A lot has changed in our planet ever since infrastructures started to build up in every country around the world. Deforestation is the permanent removal of trees to make room for something beside forest. This can include clearing the land for agriculture, or grazing, or using the timber for fuel, construction, or manufacturing. Deforestation is one of the problems that has occurred for years, and yet this problem has not been fixed. According to Christina Nunez of National Geographic, forests still cover about 30% of the world's land area, but they are disappearing at an alarming rate. But as of now, this percentage may have already increased after the wildfire that has happened in Amazon rainforest, California, and Colorado that is caused by a combination of human and natural factors.
Moreover, deforestation is said to contribute and cause both global warming and climate change. As human cut down trees, it creates emissions of carbon dioxide in the air that is supposed to be stored and absorbed by trees. Thus, as trees significantly reduce, the carbon dioxide in the air will at the same time release, which is apparently needed as trees will release oxygen in the air by storing carbons in trees and soil. By cutting trees and other plants, may it be wildlife and humans, particularly the animals, can cause famine, insufficient shelter, and resources. Moreover, due to shortage or decrease of habitat, some of them may have no place to live or food to eat. Thus, the animal may experience vulnerability to other changes such as climate change, starvation, floods, wildfire, natural disasters, predation, and those who often plunder or kill animals. As a result, this could increase the possibility of extinction and decline of other species. Similarly, humans will also get affected by natural disasters, climate change, floods, and starvation. Another impact of deforestation is soil erosion. However, humans are often the ones who suffer from soil erosion due to the fact that this threatens the environment and also the human health. Also, considering the fact that this could be spread through the use of wind, and by bringing an amount of dust that will lead to factors such as pollution and sedimentation in streams and rivers, it could also cause flood in certain areas. This also carries diseases such as tuberculosis, which is relatively fatal to human health.
Flora.
The term flora expresses all the plant life on our planet. In Roman mythology, Flora is described as the goddess of flowers, plants, and fertility. Flora has three subcategories, and these are native flora, horticultural and agricultural flora, and weed flora. Native flora are indigenous plants that have developed over 1,000 of years in a certain area. Horticultural and agricultural flora are the plants that are being used and consumed by humans. And lastly, weed flora refers to all plants which are considered undesirable in a particular area. Flora is the foundation of life on Earth. Animals rely on it in order to live, and as well as humans rely on the consumption of plants and animals. Without flora, our natural system would collapse.
The nitrogen cycle.
Nitrogen is one of the primary nutrients critical for the survival of all living organisms. It is a component of proteins and nucleic acids and is essential to life on Earth. The steps, which are not altogether sequential, fall into the following classifications: nitrogen fixation, nitrogen assimilation, ammonification, nitrification, and denitrification. Humans have been exerting an ever-increasing impact on the global nitrogen cycle. Human activities such as making fertilizers and burning fossil fuels have significantly altered the amount of nitrogen in the Earth's ecosystems. Nitrogen fixation is a process in which nitrogen gas is converted into inorganic nitrogen compounds. A much smaller amount of free nitrogen is fixed by abiotic means and by conversion to ammonia through the Haber-Bosch process. Nitrates and ammonia from nitrogen fixation are assimilated into the specific tissue compounds of algae and higher plants. Animals then ingest these algae and plants, converting them into their own body compounds. Remains of all living things and their waste products are decomposed by microorganisms in the process of ammonification, which yields ammonia and ammonium. And lastly, nitrification, a process carried out by nitrifying bacteria, transforms soil ammonia into nitrates, which plants can incorporate into their own tissues. Nitrates are also metabolized by the nitrifying bacteria, which are especially active in waterlogged anaerobic soils. The action of this bacteria tends to deplete soil nitrates, forming free atmospheric nitrogen.
The sulfur cycle.
Sulfur dioxide from the atmosphere becomes available to terrestrial and marine ecosystems when it is dissolved in precipitation as weak sulfuric acid or when it falls directly to the earth in the process called fallout. Other ways for sulfates to be introduced to terrestrial and marine ecosystems is through the weathering of rocks and decomposition, where the decomposition of living organisms returns sulfates to the ocean, soil, and atmosphere. On land, sulfur is deposited in four major ways: direct fallout from the atmosphere, geothermal vents, rock weathering, as well as precipitation. In precipitation, atmospheric sulfur is found to be in the form of sulfur dioxide, and as rain falls through the atmosphere, sulfur is then dissolved to be in the form of weak sulfuric acid. In the process of rock weathering, the weathering of sulfur-containing rocks releases sulfur into the soil. These rocks originate from ocean sediments that are moved to land by the geologic uplifting of ocean sediments.
Terrestrial ecosystems can then make use of these soil sulfates, and upon the death and decomposition of these organisms, it releases the sulfur back to the atmosphere as hydrogen sulfide gas. Sulfur enters the ocean via runoff from land, from atmospheric fallout, and from underwater geothermal vents. Some ecosystems rely on chemototropes, using sulfur as a biological energy source. This sulfur then supports marine ecosystems in the form of sulfates.
Though nitrogen is abundant in the earth, making up nearly 80% of the Earth's atmosphere, plants and animals only benefit from it from its other forms. Nitrogen is crucial in protein, DNA, and other biological compound composition. In order for plants and other living organisms to utilize nitrogen, it first undergoes a process called nitrogen fixation, which requires a large amount of energy, which explains the reason why it has a smaller percentage compared to its gas form.
Specifically for the sulfur cycle and its negative effects on the flora that inhabit our bodies of water, due to our excessive burning of fossil fuels, we are releasing more sulfur dioxide to the atmosphere, which will in turn be released back to the water as precipitation. The effect of this is that it lowers the pH level of the bodies of water in which the precipitation falls upon. And due to this, Many species of flora dies out when the pH level of the water they inhabit becomes too low.
Increased emissions of nitrogen-based trace gases such as nitrous oxide, nitric oxide, and ammonia. The trace nitrogen gases causes environmental effects both while airborne and after they are deposited on the ground. Intensive fertilization of agricultural soils can increase the rates at which nitrogen in the form of ammonia is volatilized and lost to the air. It can also speed the microbial breakdown of ammonium and nitrates in the soil, enhancing the release of nitrous oxide.
Even in wild or unmanaged lands, downwind of agricultural and industrial areas, rain or wind-borne deposition of human-generated nitrogen can spur increased emissions of nitrogen gas from the soils. Nitrous oxide is long-lived in the atmosphere and contributes to human-driven enhancement of the greenhouse effect. Nitric oxide is an important precursor of rain and photochemical smog. All of the more than 20 tetragrams per year of fixed nitrogen released in automobile exhaust and in other emissions from fossil fuel burning is emitted to the atmosphere as nitric oxide.
The burning of fossil fuel, such as coal and oil, releases previously fixed nitrogen from long-term storage in geological formations back to the atmosphere in the form of nitrogen-based trace gases such as nitric oxide. High-temperature combustion also fixes a small amount of atmospheric nitrogen directly. Altogether, the operations of automobiles, factories, power plants, and other combustion processes emits more than 20 teragrams per year of fixed nitrogen to the atmosphere. All of it is treated here as newly fixed nitrogen because it has been locked up for millions of years and would have remained locked up indefinitely if not released by human action.
We may not notice it, but human activity has increased the amount of sulfur in the atmosphere and within the ocean to meet our society's demands. One of the most common causes of the increase in sulfur in the atmosphere is burning of coal, fossil fuels, and other natural gases such as gasoline, which is used for the fuel for our cars. And another example is the LPG, or liquefied petroleum gas, which is the product of petroleum refining, which is used for the fuel of our stoves in our kitchen. Another human activity that contributes to the increase of sulfur supply in the atmosphere and in the ocean is drilling and mining. As the mining drills goes through the earth, the supposed undisturbed air packets within the earth is then released through the atmosphere or in the ocean, depending on where the drills reach these packets. So with all this sulfur in the atmosphere, what happens to the land now? Because of the low supply of sulfur beneath the earth, nutrients needed by plants to grow is now low on supply. This has been happening in Europe's soil, as it was examined that the soil used for farming within the continent lacks nutrients because of the increase in acidity in rains, which has been detected with the acidity of 5.6 pH, which is a big gap to the normal rain, which has 4.3 pH acidity level. And ironically, the solution to increase the nutrients in the soil is to use fertilizer with sulfur components.
We, as the fauna component of our ecosystem, form a symbiotic relationship with the other flora components. But with the way we adhere to the needs of flora, Our relationship can be seen more as parasitic when it should be more mutualistic. One thing is certain about our relationship with flora is that it does not need us humans because it can survive without us. But the same cannot be said with the other way around, as we are now getting closer from making this issue into an irreversible catastrophe. The result of which will be our demise, but not of the flora and other fauna. Seeing as the flora is an integral part of our ability to live, we must take action in restoring the health of the flora components of the ecosystem and aim for the day that they will be able to flourish in this planet that we live in. And we return to a time wherein we truly care for flora and we can both mutually benefit from each other's niche.